quick introduction. I'm usually the guy that does the post-quantum talks within wolfSSL, but today I didn't want to be just another post-quantum talk in this conference. Have you ever thought you would ever hear the words "just another post-quantum talk"? That's funny. So yeah, this is the agenda for today. We're going to talk a bit about our wolfcrypt FIPS 140-3 level 1 product. Going to go a little bit into the details about post-quantum, and we're looking at target distros and what we're doing in terms of what we're calling the full Linux FIPS 140-3 experience. And then we're going to talk a little bit about implementation stories, and we're not going to go into deep technical detail here. This is more of a kind of, hey, this is what we're doing, and we want everybody to know about this. Okay, so let's talk about FIPS. In this conference, I don't think FIPS needs a lot of introduction. I think everybody that's here knows really what FIPS 140-3 is. Just know that we recently got our 2 certificates, and both of them are expiring 5 years after start. So 4718 is a 140-3 cert, and it expires in 2029. 5041 is also expiring in 2030, so that's pretty good. We have 2 more coming up. One's in the pipeline, and that's for the SRTP KDF and all these other little kind of AES modes, and we're adding a lot of other algorithms into the boundary. And my personal favorite one that's currently work in progress is our post-quantum module, which will include MLChem, MLDSA, XMSS, and LMS, which will be verify only. So in terms of licensing model, we're expanding to 2 different licensing models. We can do what's called the evergreen mode, which is like a subscription model, makes it easy for everybody. And then we've got a laddered approach, which is like you go year by year as your stuff is expiring. And so I'm not actually the FIPS 140-3 expert within wolfSSL. We've got webinars. Of note, I forgot to say that there's ways to get these slides from me, and that was up on the first slide that gave an intro. You can just email me and you can get these slides, because obviously you're not going to memorize these YouTube links, right? Oh yeah, speaking of post-quantum, let's just throw that in there a little bit. wolfSSL has a lot of post-quantum algorithms. They're listed right there with their parameter sets. LMS and XMSS are just too many parameter sets to list, so we're not really going to talk about it. But we've got them as hybrids in TLS 1.3, as well as for authentication as well. Within the X9 banking standards group, there's an effort to try and standardize on what are called chimera certificates, and we're already supporting that. So we're helping out with the X9 group there. I probably could have done a whole nother presentation on what we're doing with X9 and these alternative certificates. Sorry, these certificates with alternative signatures and public keys. In the extensions, as well as the TLS 1.3 handshake extensions. But yeah, I guess that's what we'll be doing next year. Yeah, and so on our roadmap, we have SLH DSA and FNDSA. In terms of integrations, one of the things we're really proud of is if you go to the AWS transfer family blog, AWS has very kindly written a blog about how to do interop with their post-quantum stuff and our post-quantum stuff, so that's really neat. A lot of people aren't aware that curl is actually part of wolfSSL. Daniel Stenberg, the lead developer of curl, is actually an employee of wolfSSL. I was actually the person that made curl quantum safe, and so when that happened, we did a big curl release, and he actually credited me, which I'm kind of like to pat myself on the back sometimes. We got post-quantum S-tunnel, which is an interesting use case, because if maybe you're not even encrypting, you're doing plain text, so it's like you don't even know how to get started with post-quantum. Well, with S-tunnel, You build that, and you just talk to S-tunnel on both sides, and suddenly you're quantum safe. So that's kind of a neat little, it's kind of a neat little demo that we can do. We've done demos with WinBond, STM, NXP, and I've got an actual webinar with NXP in a month or so, so that's going to be a lot of fun. That's going to be on a microcontroller, so post-quantum algorithms in TLS 1.3 on a microcontroller. That's an exciting one coming up. Okay, so let's talk about these target distros. But before we do, we have to talk about the distros that already have FIPS on 40-3. And this one's almost has it. So I've been talking to Rocky Linux, and they're on their way. They're on their FIPS on 40-3 journey, and they're probably going to be available by late 2026. Although now that the U.S. is having it shut down, we're not really sure about that. But we'll have to kind of have to keep a conversation going with them. This is a really interesting slide. Which distros already have FIPS? And if you look at it, all of these distros, it's kind of a weird patchwork of some of them are 5-year full-on, what are they called? Full-on certifications, whereas some of them are interim certs, right? So we're looking at, for example, Red Hat has a few interim certs. Ubuntu and SUSE are, I think they're all interim certs. We did a little bit of research. I could be wrong. Anyone in the crowd needs to correct me, go ahead. But what's really most important on the left, far left, we can do all of these libraries by pulling out the crypto underneath them and popping in our crypto with just one cert, one FIPS on 40-3 cert. So, like I said, we're doing Strong Swan, libgcrypt, GNU TLS, OpenSSL, both at the 1.1.1 as well as the OpenSSL 3, and we can get NSS in there. But most interestingly is the kernel. So we have a kernel module that's actually FIPS on 40-3 certified. And again, it's using the same certificate. So I don't really want to get into pricing, and some of this might be inaccurate and wrong and old, so I'm not really going to go into that. But yeah, it can be expensive. FIPS can be an expensive endeavor when you're doing this in volume. Our licensing model is a lot more flexible, and we're not going to... It won't be cheap. It won't be like super cheap for wolfSSL either, but it'll be flexible in a way that we can kind of come to terms. So what distros do need FIPS on 40-3? Well, one of the most interesting ones is Yocto. I think if you're going to be in a constrained system and you're wanting to use embedded Linux, you're probably going to be on Yocto, and really there's probably not going to be a simple way to get FIPS on 40-3 without us. We're going to be the best bet in terms of Yocto. But basically, all of those distros that you see right here, nobody's really thinking about FIPS for them, and we can help out in that sense. And not just those distros. There's like literally hundreds of distros out there, and we'll help you get yours up and running. Yeah, and we'll talk at the very end about a special use case that we've been doing. So let's go into OpenSSL and the implementation story there. OpenSSL in this conference needs no introduction, so we'll probably go really quick through this. And so yeah, right now, so the previous versions, the 1.1.1 and 1.0.2 are old, not maintained, but still used. You'd be surprised how many people are still using 1.0.2 and 1.1.1. The 3.x.y is obviously actively developed right now. So which would you use, Wolf Provider or Wolf Engine? The algorithm is very simple, right? If you're using 1.1. Anything with a 1 on the front of it, or anything other than 3.x.y, you're going to use a provider. Everything else, you're going to use an engine. And so we've got both. So I passed out a couple flyers. Hopefully people are passing them around. These are the applications that we've built on top of wolfSSL, on top of OpenSSL with the engine underneath and tested. So this is how we basically, a lot of people like to ask, how do you test your stuff? And what we did is we didn't really write a lot of apps, or write a lot of tests. Instead, we used the test infrastructure of other libraries and applications, and we put them there. And we use their testing infrastructure to make sure that our stuff works with theirs as expected. So you can find all of those things as OSP in our OSP repo. They're integrations on top of OpenSSL, basically. Sorry, on top of OpenSSL. Now they can work both with our compatibility layer as well as OpenSSL and then the provider underneath it. So what are some clear differentiators? You know, sizing on embedded Linux. When you're on a constrained system, we're probably going to be a good choice for you. You know, if you're on a constrained system, maybe you have a lot of memory, so you want to trade that off for footprint, or you have a lot, or you want you don't have a lot of memory, so you're willing to trade off the speed. And so we can help you with that. Not only can you do that, but we can get into a consulting arrangement where you list your requirements with us and we get you there. We are very responsive to vulnerabilities. Within 36 hours of determining a vulnerability is a vulnerability, we will have it fixed within 36 hours. And then if it's considered severe enough, we will get a release out within 1 week, within like 3 days of that. And places where OpenSSL can't go, such as bare metal and real-time OSs, we shine. We do very well there. Okay, so NSS, how does that work? Well, if you look at NSS, it's a series. If you look at something like Firefox, it's got a series of libraries, such as a UI library, a rendering library, all these other mini libraries that are inside Firefox. One of those libraries is called NSS, and that provides the TLS for it, and all the kind of protocol stuff that's going on. Within NSS, all the cryptography is kind of abstracted through what's called the PKCS11 layer. And what we can do is we can replace their PKCS implementation with our PKCS11 implementation. We've got a product called wolfPKCS11. So we pop theirs out, we push ours in, and suddenly you're using our wolfcrypt FIPS underneath of that. So as engineers, we like to have a little bit of fun sometimes, and our management was asking us, okay, so are you sure this is working? Are you sure like it's gonna work in every use case? So we took the most common use case, which is YouTube, basically for your web browser. YouTube is the most common thing out there, and we basically rickrolled the the management. They started playing. They started doing a screen share and got Rick Astley's "Never Gonna Let You Go" and played it while wolfPKCS11 was loaded into NSS. So that was basically a live test case for the management. As you can see, in cryptography, you rarely get to show a nice UI. So this is very special to us. The wolfSSL HSM slot ID 0. Okay, so what are applications supported by NSS and wolfcrypt? So we can do obviously the NSS tools as well as Network Manager and libpoppler. I'm actually not really familiar with what libpoppler does. Someone can let me know about that when later on. So what you noticed about the previous two, which were OpenSSL and NSS, was that was a real-time kind of plugin. And you don't actually have to rebuild those libraries. In terms of libgcrypt and GNU-TLS, we do have to rebuild them because the code, their crypto implementations underneath are being overridden. So we take those implementations away and we put ours in. Okay, so for those projects, we can basically, these are the kind of, there's lots of projects that we actually support for doing that, and we've tested, but the most important one to us is CUPS, right? wolfSSL actually has a lot of printer customers, and so we've we've made sure that CUPS works with this stuff. The other really nice one is VNC, because VNC is actually used as the backend for many other kinds of apps for virtualization. So, and you know, systemd obviously is a big one, and we've tested all of these, and we know that they work very, very well with what we've done. So finally, we get to the Linux kernel. The Linux kernel is really interesting, right? And this is how we do it. If you look at a Linux kernel, there's like the memory management area, process management, you know, bus management. But then everything else comes in as modules, kernel modules. So if you want like your sound system support as a kernel module, your Bluetooth support comes in through a kernel module. Well, one of those other modules is for crypto, and so we can bring in libwolfSSL as the cryptography there. So how does that work? Well, from the Linux kernel crypto API, there are these priorities for each of these algorithms. And what we do is we basically set ourselves to the highest priority that we can, which is about 100K, which is kind of ridiculous, but that's okay. And that means that you're basically going to be using us by default from there on in. Now, can the user set that lower? Probably, and then are they going to shoot themselves in the foot? Yes, but I mean, we're just going to tell our users not to do that. Don't set us lower. Now, use cases for the kernel module. So we're looking at cryptographic offload of disk encryption, right? That's a big one. Anyone who wants to do full disk encryption has to do the cryptography in the kernel. So that's where we come in for this. So we're looking at dmcrypt, LUKS, and fscrypt. In terms of cryptographic offload for network packet flow, we're looking at any kind of VPN software that does all of this stuff in the kernel, so they don't have to go down to the user land. And then one of the most interesting things is what we call WolfGuard, which is just WireGuard, but WireGuard with FIPS 140-3 algorithms. And we can do that at the kernel level. So you can have kind of like a WireGuard-like system, but instead of using the WireGuard algorithms that the WireGuard chose, you can be using FIPS 140-3 algorithms. And so again, we have another webinar about this, and it goes into a bit more detail than I can here. So the summary is basically one crypto library to rule them all, right? In order to sell to the government, so the US and Canada, you kind of have to be FIPS 140-3 certified. And we'll make it simple and as easy as possible as we can for you. So the use case, normally we can't really talk about our customers, and we have to keep confidential who they are, and you know, that's just the way things are. But iGel was one that we're allowed to talk about because they spoke about us first. So iGel is working together with us, driving this effort. And they're a really great company. They've got a kind of a custom Linux distribution that they use for their customers. And so this project that we're doing is integrated into their products. And the reason why they're doing this is because of everything I've said before, right? Flexible licensing. You know, we've got certs until 2029. They're not interim certs. They're guaranteed for 5 years. And as wolfSSL, the way we work is we're always going to have new certs, right? So we're always going for new certs. Like I said, we have 2 in the pipeline and 2 already for 140-3. By the time those sunset, we're going to have ones that are sunsetting 5 years after that. You'll always have a rung on the ladder to reach for when you're working with us. Another great reason to go with us was when you do this, we only, like I mentioned, only 5 libraries. There are 5 ways of integrating, but there's going to be other ones. And like one of them, for example, on the roadmap is to take the crypto and boring SSL and put us underneath there, and then you'll have a FIPS 140-3 certified boring SSL. Oops, I pushed the wrong button. There we go. And that's it. Wow, 5 minutes left for questions. I'm guessing there won't be too many questions, but if you're shy, you can also email us at facts@wolfssl.com. and let us know what you're thinking, what questions you have.
Can you go back to the slide where you were mentioning about MLTSA and PQC compliant
The
digital
post-quantum
signatures?
Yeah, that's pretty far back. Hold on.
Yeah, I think it's in the early slide somewhere.
There we go. Come on, yeah. In process. This one.
Yeah. So can you explain what stage you are in, wolfSSL, whether you can support all this? Because now that the FIPS publications are out, but
Yes.
there's still implementation gotchas about those.
We're good to go. So the history of how we did our post-quantum integration was wolfSSL was quantum safe in 2010 via security. We used N-True and N-True security. We used N-True from Security Innovations, and we did an integration where you had to build their software, and then we would call into their APIs. That was in 2010. Then I was hired about 4 years ago, and my job was to kind of update that. And what we did at that point was integrate with libOQS instead. So we used libOQS's implementations, and then used that to build up TLS and the other various protocols such as SSH on top of that. Now with standardization, we know what the algorithms look like. We know the specifications. We no longer need libOQS's implementations. We now have our own implementations of all of those, and we are going to have them. We predict by the end of the year we'll have them at the CMVP for validation with FIPS 140-3. You're welcome.
So I have lots of questions.
Lots.
But I will give other people a chance to ask as well. But let's start with the first one. Do you have an entropy source in the libwolfSSL kernel object, or maybe also in the other implementations that you have?
We have what we call wolf entropy. So there's a -- enable entropy. But usually we depend on the entropy source of the operating system.
Which does not really work if it's a kernel module, right? Or do you depend on the one that the kernel has?
Like I said, we can do wolf entropy, which is a jitter-based system. But in the kernel, we would probably depend on the kernel one, yeah.
Okay, so the wolfSSL KO does not have an entropy validation certificate, or does it have one?
Not yet, no.
Okay.
Yes.
Does somebody else want to ask a question? Okay, you mentioned that you were testing, you had a list of implementations that you were testing GNU TLS with. One of the main users of GNU TLS is the GNOME desktop,
Yes.
but you did not have it on your list. Is there a reason why you're not testing the main user of GNU TLS?
So probably one of the reasons is because it's a user interface, which makes it a little bit harder. I should go back. That's a good point. I will go back and say, hey, so maybe you're a bit more familiar with the GNOME system than I am. Do they have a set of tests? Is there a make test command?
I'm sure there's something. There's some layer that abstracts this, but I would have to defer to one of my developers to tell you more details about this. But
yeah.
Send me an email. I can.
I think the best idea is for me to go back and ask my developers, was there a reason? I think we try to do as much automation in our testing as possible, and so UIs generally are harder to do that with. But I'm making that up. I actually don't know. I'm just guessing. But I think it is something that we should. You're right. It is the biggest consumer of it, so we should be doing something with that. Thank you very much for bringing that up.
Another opportunity to get the mic. Okay, do you, you have a long list of commonly used implementations that need crypto and solutions for FIPS for that. But one that is curiously missing and also widely used is Go. Any plans to have a FIPS certified wolfSSL setup that could be used by Go's crypto libraries?
Yes, we actually have WolfGo, or Go like a Golang wrapper. So we're already Go enabled. We didn't do it with this because, like, how do I explain it? We already have it available, so you would just build it like that. You don't need to kind of pull anything out and push anything in. We're already supporting Go. Actually, you're probably right. I should have just made a Go slide. I could have done that. Yeah. We already support Go in the crypto provider in Go.
Do we have time?
We actually have like 3 minutes still, so you can ask more. But yes, if nobody have a question, you can also discuss in person. Depends on you.
Go for it.
Okay. Like on the OpenSSL slide, you said you were testing with OpenSSH, but the OpenSSH actually likes to implement some of the algorithms their own and not use the OpenSSL implementation. Are you using a patched OpenSSH for that, or?
No, we're using, there are calls into from OpenSSH into OpenSSL, and we're just using whatever is normal there. If they implemented their own, we didn't really change it that much. We're just using what was default there. Yeah. So it may be, you're right, it might not be that might not be an intensive test, but I mean, what we're doing here is just to kind of show that we're able to be used by these various libraries, and to get some confidence in our own implementation.
Amazing.
Last chance.
Come on, someone else.
It's great that you do my job. Yes. Last chance. Anybody else who wants to ask?
Before we end this, there are stickers up front, and I want to give everybody here a wolfSSL sticker, so don't go away. Also, I was passing around there should be a pamphlet going around that talks about how many things Wolf Provider works with. So please do pass that around.
And I, of course, there's one more question.
Hit me.
Oh, yeah, there's somebody else.
Oh, wow.
Yeah, just a quick question. So what lab do you use, and what is your experience with your lab for FIPS validations?
Beg pardon?
What lab do you use?
Oh, we
for your
used,
FIPS validations?
oh God, what are they called? Aegisolve. So the 4718 was done by Aegisolve, and the other lab was, oh God, I couldn't tell you. I actually don't know the lab, but I know.
We can look it up.
Yeah, I know the first 4718 was done by Aegisolve. They're down in the United States. Yeah.
Amazing. Thank you for your interest. It was amazing. Many questions. Thank you, Anthony, and big applause for him, please. Anthony, thank you so much.